can't do anything about it. Just hide this one at least.
Yeah.
Not this one, hide.
Okay, sorry.
That's it.
So, who am I? I'm Martin, work for NVIDIA. I'm a Gerrit and jgit maintainer. Been so for a while, except for the jgit part that's just recent. So I'm going to share some stories about some of the things I've been doing in the last year. I started at NVIDIA a little over a year ago, exposed to lots of new great problems to tackle. With Gerrit, we use Gerrit very heavily. So that, and in very varied different types of cases. And so that means I'm exposed to all sorts of problems that I haven't seen before, and they're not the same across all our servers. So mostly, you know, I started and, first I want to say I love questions. So a lot of this will be driven by that. If you have questions, I'll spend more time on something. If not, I'll probably just breeze through it. So please do interrupt me. One of the first things I, started to do when you have problem servers, I try to study some of the Gerrit logs, see what you can see in there. From that, in the first few weeks, I was fixing issues and finding that when you're sending data, that someone's doing a fetch, every now and then you get some failed fetches that are, have exceptions in the logs, and a lot of times that's because of repacking. So if you're from, running server, constantly repacking. If you're trying to read from a file that just got consolidated and deleted, it usually causes an error. So this is particularly a problem on NFS, because if you have the file open on your own client on NFS, even if it gets deleted, you tend to still have a file handle it and it's fine. But if you are on a different client than where it got deleted, that usually isn't the case, and you'll get a stale file handle. So one of the things I noticed is the way Git sends objects over the wire. It tends to send a header and an object one at a time. They might be in various formats, it might be compressed, etc., but it's going to send them sort of in blocks, right, each one. And so before you send an object, if you make sure you can actually read like the first section that you're going to say, because it tends to split it into buffers, like how much it's going to send at a time. If you make sure you can read it before you send the header, then if you find an IO error trying to read the header because the file's disappeared, well, you can start over and you can go look for the other representation because you just repacked it into a new file. So doing that, I was able to recover a bunch and eliminate all these exceptions from my logs. So that's the first change that did that. There's some other use cases very similar, and another change that did that. So that makes things way more reliable for us now. Some other things I found studying the logs. jgit had a bug, and it was looking at temporary pack files. During repacking, the Git creates a temporary pack file while it's building it, and then it eventually renames that, right, to a name, but originally they start with temp underscore, and when you're creating bitmaps and stuff, those temp files actually sit there for a while as temp files before they get renamed, even though it's completed. And so jgit was actually looking at those when it really shouldn't quite be yet. So because there were like error messages every now and then referencing them. I'm like, what? Why is it talking about temp file? And so I investigated it, and I'm like, that's fishy, right? And then I realized, it's just not filtering them out. It was that simple. It just looked at everything in the pack directory that had the pack extension. So fix that. So studying the logs can be more useful than you think. It would be good for us to clean up the logs so it's easier to do this, because we have a lot of data in Gerrit in the logs. So and a lot of it comes from jgit. We have a lot of still intermittent errors that go into there because of repacking, but they're not really errors, or they're in retries, and we really should just get rid of those from the logs because they're not useful for us.
Yeah, pack file invalidation is very verbose.
Yeah. I would love to fix that in the future. All right, next thing. When I ran into problems that I hadn't seen before, started studying my JStacks. If you're not, a JStack is just a Java stack dump. You can run it on your live servers, and you'll find lots of hotspots there. If you study them enough, you'll see repeated patterns. Sometimes it's the thing you're looking for. Sometimes it's just noticing patterns that you see a lot. So one thing I noticed is that there was a lot of time being spent doing some optional stuff, and this was actually some code I had added when I was at Qualcomm a few years ago to make soft references to index files. So jgit caches a lot of pack data, and it has a block cache where you can tune a lot of different settings in there about how much it caches at. But it also caches every index file for pack file, and there's no settings on that. So it caches that no matter what, if it's read it, until it gets rid of the pack file. And that's something that I fixed when I was at Qualcomm, because when we had large servers with a lot of repositories, 10,000 repos and stuff, and you just did an LS project, it would end up like running out of memory from it. So
does this include the indexing of preserved pack files?
it probably does, yeah. So that's probably...
Okay, so that's fixed. Okay, so preserved pack files are, you also created a concept, right?
Yeah, yeah.
It's a way of like hard linking pack files into a dedicated directory rather than pruning them immediately, which might cause file descriptor errors in the jgit server. Yeah.
Right. So, but in general, even without the preserve, having sort of unlimited caching kind of is not a great idea. So if you turn on soft references for jgit, then it will also soft reference your indexes these days. And so that was useful. But in doing so, I introduced a bug. So, sorry, I'm getting ahead of myself. That's the next thing I'm going to talk about. So then here, one of the things I noticed in the JStacks, there's a lot of time with the pack file itself, the Java pack file, doing a lot of waits. They would block, a lot of threads would block on each other. And we have a lot of threads on our pretty big heavy server, so we get a ton of HTTP traffic, and it's not even all like Git traffic. A lot of it is REST API usage, and that really contends on the pack files, and a lot of it has to do with when jgit opens a pack, it often reads the index, it often reads the bitmaps, it might read the reverse index, and it just had one global lock to do all that. So even if your code didn't need one of those indexes, it was still potentially waiting on another thread reading those indexes. So I noticed that big global lock, got rid of that. So now if you only need the index, which most things need, then once that's loaded, you're not going to block because someone else is reading the bitmaps if you don't need them, or if someone's reading the reverse index. All right, so then the next thing is when you're in there modifying a lot of this code, you learn a little bit about it, and then sometimes things become obvious from just reading the code. And so here's two different improvements I made for that in the last year. Here, it was just a class that had some conditionals in a function, but it was kind of constant because it was overriding the class in two different ways, and both of them just had returned either true or false for that entire class type. And the parent class type had a conditional, and I just got rid of the conditional, returned true always, and it sped things up a little bit. That was, again, something, that was just obvious when looking at the code, like, wait, why are they putting a conditional there? Why does it keep jumping on me?
Sorry, how do you measure the improvement that these changes make?
So usually I try to find a use case that I think is going to be affected by it, right? So often, most of these are fetch use cases. That one, I don't remember, you'd have to look at the specific code to see how much, yeah, so this saved like a second on a 31-second fetch. It's not a lot, but it was consistent. So, and that's kind of like my theme here a little bit, everything counts in large amounts. So a lot of these improvements weren't massive improvements, but when you get a whole bunch of little ones, they can add up. So fetching is kind of the worst case. You know, if you're doing a clone or something, you'll particularly notice that type of thing. The next one, oh yeah, so it says it right there. And then this is another one I found while reading the code. jgit is constantly rereading the pack directory because obviously garbage collection creates new files. As soon as it detects that there's new files, it goes through and reads things. If it runs into a problem, it reads things. One of the things it was doing, as soon as it found a new pack file, it was going and loading the indexes, the bitmaps on it. And I was like, well, why is it doing that when it's iterating? It may not really need it yet, right? So if you're trying to get something and you were blocking on loading the index, the bitmaps, that's going to slow down your traversal. So I made that lazy, and it doesn't show up as hotspot anymore. So one of the things I notice a lot on our service is you watch the metrics. You can see a spike in the HTTP threads whenever GCC happens, right? Things slow, suddenly you get a ton of spikes because there's constantly requests coming to the server, but they slow down a little bit. And so the thread count rises, and then it slowly comes down after HTTP and then after GC, and the next GC happens, and you get the sawtooth pattern of threads. And the length of and how high it would get was pretty high when I started making some of these improvements, because a lot of the problems only showed up right after GC. We have really good caching because we only have a few projects on this server. So the block cache is really good, and it tends to not do a ton of I/O after it's already cached it. But GC comes along, repacks, creates new files. The old ones disappear. It has to reread everything. So you'd see these massive spikes every hour or two.
But you can't get rid of those, right? I mean, they're going to be new. There's going to be new pack files to be loaded.
There's going to be new pack files all the time, but the key is to figure out why you had those spikes. Like, what is getting slow? Is it just the reading, or a lot of it was all these little things like blocking? Like, okay, so it's noticing there's a new file, but it doesn't really need to read them yet, and it certainly doesn't need to block all the threads because there's a new file. So getting rid of that has drastically reduced my spikes. So it's not something you can necessarily easily measure, like in a single fetch or something like that being faster, but you'll notice it in your server log, in your stats there. Your latencies, you won't have those latency gaps effectively. All right, some more things. So this one's a little bit bigger. So right when there's a lot of pack files potentially, and jgit, when it wants to send an object, it's going to try and pick the best pack file to send it from, so the best representation of that object. So this is the one you guys knew about. And it did a linear search over all the packs, and the more packs you have, you know, if you haven't GC'd in an hour and you got 500 new packs, then it would get slower. So, this is a different, yeah, so this is, and some candidates it can't use. Sometimes it decides, okay, you know, I didn't find what I wanted in one of the pack files. Probably because maybe it's deltaed, and it's deltaed against something that the client doesn't have, and that you're not going to send or something. So it ends up needing to send the full object. And so it can't use the on-disk representations, any of them that it found. And so one of the things I noticed, it was just discarding that data if it couldn't use any of them. And then it just went and did a search again to find the one that, because then it just says, well, give me any of them, and I'll unpack it and repack it to send it. Well, it was forgetting, instead of like researching again, I just reuse at least the worst thing we had. And that showed its savings too. So there we go, that saved like 3 seconds on a 41. That was pretty simple change. All right, then I found some things studying flame graphs. Are you guys familiar with flame graphs? At all? Yeah.
Yeah.
So this one's a fun one. We have timeouts in jgit, right? So we have timeouts on sends and things. If a client doesn't respond in a certain amount of time, things are going to timeout. So how does that implement it? Well, there's a timer. And the timer, the way it works is it starts a different thread. And then every time it's going to send a few bytes, it says, go ahead and start. And then the other thread goes to sleep, and it wakes up after that time. And if it's still sending bytes, then it sends an interrupt to the original thread. So it does this, and it basically, if you're sending a bunch of stuff, for every send, it's going to start the timer, then it'll send some few bytes, and it'll stop the timer. Then it'll do that again and again. If you're sending, an hour, it's doing this millions of times, right? But to start and stop the timer, since it's in another thread, it sets up some data, and then it calls notify. The other thread wakes up and does something with it. So I actually outlined this a little bit. Here's the code, but let me show you sort of the flow. So there's your main thread. It starts the timer, sends a notify. This other thread, the timer thread, is basically constantly in a loop. It's in a sleep loop. So it's always waiting to be interrupted, either after like a default of 1 second, or if it gets interrupted by the other side. So then the first thing we do is we notify it, and we tell it, oh, okay, here's our deadline, right? We need to be woken up in 10 seconds or something to time out. So then we do some work, and we send a stop. So it sends a notify to stop it, because it's done. So it sets it back it clears the deadline and sets it back to its wait loop of just 1 second. So that's kind of a normal flow, the way it works. Then, in a timeout fashion, it's pretty similar, starts it, sends it, but while we're sending bytes, it actually wakes up because it times out. So now it goes and interrupts the thread, and it works like that. But after it interrupts, it goes back into a wait loop, so that and then it gets interrupted again for the next start. So the notifies were showing up in the flame graph. I'm like, okay, why am I seeing all these notifies? And it wasn't taking a ton of time, but again, it was taking like a good second or so on maybe like a second or 7 second or 10 second LS remote, like just when you're spitting out all the refs, it was constantly in between each spit. Each ref, it was basically doing this or something. So, here's just another case. So because the code is already written in case, timing's not always perfect, so it could wake up earlier, and if it did and it said, oh, the deadline actually hasn't been reached, so it just goes back to sleep. So that means this side has a loop that's pretty smart already. It handles like a lot of edge cases. So I'm like, well, we can take advantage of this, right? Why do we care to notify it that it stopped? Right? We don't really care, because it's going to wake up and notice that the deadline's cleared anyways, and it's not going to bother interrupting us, so we can just eliminate that notify. So that's what I did. So now when it wakes up, even after the stop at some point, it just, oh, there's no deadline, so it goes back into its wait loop and waiting for the next start. So that was a simple one. That increased things a little bit. And then I realized, but wait, I also don't necessarily need to wake it up to start it either, right? If it's asleep, but it is planning on waking up before my deadline, all I need to do is just tell it the next deadline and let it wake up on its own, right? So now the logic is a little bit smarter than that. It doesn't do that anymore. Or that's this one, I guess. Right, so it doesn't, maybe I didn't show it well. But it doesn't need to wake it up. So that's what those two changes were. So 2 little changes to the way that works, and that saved a significant amount of times on LS remotes. Okay, sharing is caring. So this is jgit does have a window cache, and we do GC regularly. And when you do GC, you end up deleting a bunch of files. You've got to get rid of them from the cache. This was making the spike that I talked about the largest. This is the biggest thing. This was basically, the window cache is just a bunch of buffers. It's a giant hash map with buffers of like 20K or whatever you set them to. And they just represent data on disk and pack files. And when you go try to delete a pack file, there's a remove that it calls on it, and it goes through and it literally linear searches through the hash map to see if it's in the pack file that you just closed. If you have a big cache, that linear search is pretty slow. If you just ran a GC and deleted like 700 pack files, now it's doing that linear search for 700 pack files.
Really? Was it doing it per pack file?
It was, yep. We used to, back at Qualcomm, we used to have something we called the jgit bug. And I think it was this. Sometimes the server would just go nuts. And we ended up and we would see it doing this. I never figured out that back then that was the problem, and I'm not sure it really was, because we ended up upgrading and stuff, but I think it was in further analysis. And it would we would have to restart a server when it would get in that state. Because we used to use, I don't know if you guys remember, I wrote a script called EXP roll. This is pre-geometric repacking in Git. It basically did geometric repacking, but via a script. And so we would rarely at Qualcomm ever roll over that many files because we had good geometric repacking.
Just one question. So this one is already in 3.12 or not? Sorry, 3.13. You pushed this one on jgit, right?
Yeah, I pushed a bunch of stuff to like
Because-
jgit 6.10 even, so it's in older ones, and some
Okay,
of the
that
stuff's
should be
in the
the-
newer, but everything
should
should
be
at least
Maybe
be in
let's double check.
3.13.
Because we wanted to bump also the version of jgit before 3.13 RC3, right? So let's make sure that this one is
This
in,
is a
right?
few months ago,
Okay,
probably
so
at
it
least
should be
a
there.
half a year
Should be
ago,
there.
so I think this is in there. I think pretty much every,
Another unrelated question to that, do you shell out for Git to do the repository maintenance? Or do you do the repository, like repacking of pack files and so on? Or do you do that in jgit itself?
that depends on who wants to do that. At our server at NVIDIA, and also at Qualcomm, we would use cgit. So we wouldn't shell out, we just have cron jobs typically.
Okay, yeah, because it feels like a lot of the problems that you're talking about are because you basically shell out to Git to do that, and then you basically have to catch up with what it was doing.
A little bit, but I think it would have the same problem even you can run it in Gerrit, you can run repacking in jgit.
Yeah, but I mean, like mostly also the thing that I talked about where you always have to rescan the directory every single time. I mean, that would basically go away if you did everything from Gerrit itself. Because you wouldn't
Maybe,
have
but
to
not if you're in a
rescan-
multi-primary environment.
Okay.
But that's an interesting point. But I want it to be resilient in every case, right?
Fair enough, yeah, makes sense.
So, yeah.
Yeah, the memory footprint of executing that maintenance within the Gerrit heap usually affects other Gerrit operations.
It tends to be prohibitive on larger installations to do it in jgit. jgit's more of a memory hog.
Yeah, so I suggest we go then Gerrit 3.13. Shall we? How much time?
As much as you want, really. I've been for about 23 minutes, so let me go at least, 10 minutes? I can move a little, but this was cool. So what I did here is I added the bulk method and still do a linear search, but I have a set. I use a set so that it can compare and say, well, is it any one of these pack files as opposed to just one at a time. That helped a little bit. It didn't help enough. And part of that, I believe, was, I don't know why it keeps doing, don't touch it.
The hidden links that would surface when you go to the next step.
I guess, but I'm trying.
So you
Okay.
should probably always click on the upper right side because there's no utility there.
So use a set. Then I had to add another thing. What happens was the scan is probably not fast enough. So it still ends up maybe like trying to do a bulk on like maybe 5 new ones, and then a bulk on 10, or, so, you know, so it doesn't get all 700 in one bulk, is what I found. So what I tried to do is I divided the linear search into blocks. And so now a thread will try to do a block, and if another thread comes in instead of waiting, and it'll just run on a different block. And so they end up sharing it. And that made it basically go away. So that was really awesome. That was what made good use of the bulk, splitting in blocks. Bunch of stuff with optionally. I talked a little bit about that one already, the bug. I want to skip through some of this. This was a really good optimization, but it's in there. It's the biggest one. I made it. Searching for the packs, go down to 1, from O to N to 1. Basically, what I realized is the current algorithm for searching through the packs was really pretty dumb, because it always picked the last one. It didn't actually really have any smarts, unless it was a whole object representation, then it picked the smallest one. But for all the deltas, which is mostly everything, it just picked the last one on the assumption that the last one was going to be in the largest pack file. And the largest pack file would be the one with the bitmaps, it would be the one that deltafies better and everything like that. So that was the assumption. I'm like, well, why don't we just search in the reverse order and pick the first one and shortcut? So that was great. It gave me bit for bit, same pack files, and it, you know, worked well even when there's 500 pack files. So I go over all the details there. I'm just going to skip it. Some setbacks, some things that I've tried that really didn't pay off yet for me. They may pay off for you, so it may depend on not having the right use cases. I tried introducing parallel reads. When your jgit, your block cache is not full, if you have a whole bunch of threads that are reading, why not allow them read from the same file at once? I mean, these days, disks can do parallel reads fairly well, especially with NFS, or you might have a ton of disks behind it. So I introduced that, but I didn't see any performance gains. So that change. You can try it if you want. Maybe it should be merged anyways, but I found my block cache is basically too good for it to be useful for me. Packed refs. Here we kind of I think we want to do the opposite. Right now we allow parallel reads to packed refs, and that makes sense if it's changed after one read, but it parallel reads like until it takes, let's say it takes 10 seconds to read the file. If 10 threads come in, or 100 threads, and they want to read it, they're all going to read it separately, even though they're going to end up with putting the same data in there. That just kills our server. I can see it a lot. I have tried fixing it. It didn't work. I don't know why. In my tests, it makes things slower. So that's something that I can still work on. Maybe you guys have some ideas. Maybe I just have simple bugs in my code. I actually have another patch that is even simpler, and it still doesn't seem to improve things. But I know there's room for improvement here. So, you had a question?
Sorry, when you say it didn't work, it means you rolled it out and then you had to roll back?
No,
or?
just in my benchmarking. I did a bunch of pushes in parallel, for example, and reads and then reads, and it just got slower.
So you can reproduce these scenarios in a staging environment before? You don't go full commando in prod with
I haven't done that, no, because I want to at least have it look good in my tests. So this just describes what I was just saying a little bit, so I'm going to skip that. So another thing I tried, because I noticed from the flame graphs, you know, we spend a lot of time encrypting data. We spend a lot of time SHA-1ing it during fetches. So I tried to put all that in an asynchronous, in a separate thread, and just pass it into a queue before sending it out. It just seemed to shift stuff in the flame graphs instead of making it faster. I don't know why. I haven't figured it out. Maybe I don't have the right use case for it. So, oh, that was sends that I was just talking about, but also zips. So sometimes you have to inflate and send the object in a different format than you have it stored, so then you have to inflate it and then deflate it. So I put that into separate threads. Didn't see any real major improvements, but that's probably mostly because reuse is really good, so we rarely do it. So I'm guessing maybe in a different use case that would be actually worth it. Some more thoughts for the future. Okay. Repos generally only grow, right? Git dominates the market share. That means, we need to solve it, and because Git's going to be around, and if we don't solve it, we're going to lose to something new that does, right? We can only go down in market share. So we have a target on our back. And whether we think Git is the right tool to store stuff in or not, people are doing it, right? So everybody wants to do it. It's not, even if we're not designed for it, we have to figure it out. A lot of the problems that I'm going to talk about are not necessarily just large files, but let's go over some of the things. So I have one large repo, it's 400 gigabytes. It's just a problem from a storage standpoint, right? And just from a transfer standpoint. That's what most people think of as the problem with large things. Those are definitely real problems. They're not the only problems, especially in jgit. I find object count to be the largest problem from a memory standpoint. So I have a project that has 90 million objects. I don't know if that's a lot. I don't know if other people have way bigger. I might even have bigger projects. That happens to be a really busy project, so I know about it, so it's a problem.
Yeah, just to say that the largest one that I saw so far was about 40 million, so you're more than double the largest one I've seen.
Okay, so 90 million objects. What happens in this? I have a server with 1.5 terabytes of RAM. It has a terabyte of Java heap. And if I put 50 SSH threads on there to allow 50 potential upload packs in parallel on here, I can run out of memory. Okay, that's not a lot, 50 threads, right? That's not a lot. What the hell is going on? So object count is a huge influencer of memory because of Java. So it also has lots of other problems. Large files, I don't know what a large file is, maybe stuff over 40 megabytes or something. They have problems because they don't delta. Patrick's talked about this. I don't want to get into it too much. Very large files, they have additional problems that the SHA-1 calculations are now slow. There's other things that have problems with the SHA-1s. It's not just large files. It's also things that have files that have long histories. Because the more history you have, even if it's like a submodule or a manifest version where you're constantly bumping it, you have small sections of the files changing only, but it might be 10K or even a few meg file, and you have millions of revisions of that. Your SHA-1 calculations are high on that too. So the SHA-1 calculation is a problem not just for large files, is what I'm saying. It would be great to solve that and get some form of rolling hash. So those are some of the things I talked about here, some of the solutions. I advise you to look into BUP for chunk caching and find out all the other things that BUP had to solve there. And let me get on to some other things on this. So I can wrap it up here. Here's the problem I'm worried about. And no one's talked about this, but maybe it's a Java-specific problem. So Java indices are ints. What does that mean? And most of our collections in Java, your lists, your maps, etc., they have an index that is an int. That's 2 billion, because it's a positive int, not even an unsigned. So we only have 2 billion. Okay, that's 20 times my 90 million object repo. That's not very far away.
Especially with AI.
right? So, and I don't really think that's that big of a repo. I suspect many of you have bigger repos out there. So, jgit's just going to fall apart. It's ready to fall apart at some point. So this is something we really have to address in the community. And this is something I've only realized in the last few weeks.
Just to say that when we were testing our repo, because we created a kind of scenario 12 years, even if we were starting from a kind of regular repo, that we got to a point where actually jgit fell apart. I couldn't really do anything with that repo with jgit, only with jgit. So I believe we got some issues on jgit as well. So I was going to do any commands on that repo with jgit? No way. I could only use jgit. But also jgit has other limits.
I know that this is certainly a problem in Git as well because we use ints all over the place. I have been complaining about this to the community a long time already, and I'm always advocating for using size T, but Juni is also fighting back a little bit on that regard. But we are slowly addressing over these issues over time. But we also had like several security issues already because ints were overflowing. So it is an issue.
Okay, so I'm scared of that one. I'm not sure what to do. Should we look for some libraries that can just handle 64-bit? FastUtil can do that. It's Apache 2.0. Maybe we want to use that. It also handles collections of primitives way better because I don't have time to talk about it, but Java's terrible at that. There's also these two new projects that I just found out about before this, like a few days ago from Nasser. And the first one handles primitive collections well, and the second one reduces your object overheads down to 8 bytes instead of 16, which can be a big deal in Java. But I don't think, and I haven't looked at those projects too deeply, I don't think there's any 64-bit ideas in there yet. So I don't know if the Java community is going to address this. Again, I have not researched this extensively. I've just recently realized this is going to be a problem. So I wanted to put that out there. It's a fairly big undertaking. The last thing maybe really I would love to get across here is if we really want to think about moving and scaling, let's just pretend we don't have this problem, the 64-bit problem. The memory usage, right, that 50 threads that I talked about that still chewing up an entire terabyte of heap, you know, how can we deal with that? And how can we make things, I spend a lot of time figuring out lots of ways I can make object sizes smaller, and I can do optimizations all over the board, but ultimately it's an O to the N problem currently. Like, we're going to use an amount of memory relative to the size of objects that we're talking about analyzing. And if you're doing that, that can be up to the amount of objects in the repo, 90 million or so. What I'd love to do, and I think the only way we can really scale long term is if we move to a streaming concept where we're no longer O to the N. And that may require figuring out how to do, like currently jgit, you know, has to figure out what objects to send, and it creates a giant list and a hash map with things that it doesn't need and it does need. And to do that, that's why it's O to the N, but it has to figure that all out in advance before it starts sending anything, because it wants to know what it really needs to send. If we can make it start sending right away and do that whole calculation in a streaming fashion instead of holding it all in memory at once, the list, and I'm not talking about the objects, the data for the objects, I'm just talking about the metadata about the objects effectively. If we can make that not have to be all in memory at once, then we can really scale long term. And that, I think, needs a form of stream. We probably need some algorithm. I was talking with Pef about this a little bit a few weeks ago. Maybe if we can, you know, get a cache on disk that shows topological order of the objects, and we can assign a generation number to each object, then we can start walking it in a streaming fashion. and decide, yes, we can send that, and once we sent it, if it's a high enough generation, if it's the highest generation number, we can forget it after that. We can just move on. And Patrick, thoughts?
Are you talking also about generation numbers for blobs or only for commits?
I'm talking about the blobs too.
Okay, yeah.
So that's why we would need a new format and not just generation numbers, which currently are for
Okay,
commits.
yeah.
So I'm thinking
Makes
maybe
sense.
if we do the same thing for blobs, and I know that's going to be weird because it's not, but it's still a DAG, right?
Yep.
But that DAG may get wide, and the width is still what we're going to be. Then at least we're O to the W of the width, as opposed to O to the entire length and everything.
Yep.
So that's something I'd love to really think about. And it may not be that hard, but I'm trying to solicit ideas, and I want to get people thinking about that problem. All right, any other questions? No? I don't think it would.
In which situation exactly?
Well, figuring out what to send. Anyone?
No, not really.
Okay.
It's a different problem that we're solving with pluggable object databases. I mean, it might solve some of the problems that you have been talking about, but definitely will not solve all of them.
Because, yeah, it's not really a storage thing, and it's not even the object level thing. It's a graph problem.
Is jgit at all sensitive to tuning the JVM and GC parameters? I've never used jgit, but I'm seeing it.
I mean, it certainly is, and Vastev talked about some of that yesterday, and there's lots of great advice and all over, but some bad. Most of that you got to test for your use cases. I don't have any specific advice I want to give on that right now. So.
One more question to you. Could you maybe share the specific case where Git fell apart with a number of objects?
Yeah, absolutely. We'll get there, yeah. One thing, so conscious of the fact that in 5 minutes there is going to be lunch, right? It's 12:40, the lunch, right? Can you double check? So why don't we grab some lunch, right? Otherwise we're running out of food. And then we come back in half an hour or something, and we do the Gerrit 313 in half an hour. Otherwise we do it now, but then the problem is we are missing the lunch break, and we do a kind of brown bag session for Gerrit 313. What do you think? Sounds good? Okay. So let's go grab some lunch, and let's come back around 1 p.m.